All right, so here we go. We're looking at slopes. What is a slope? What does that word mean? And how do we actually figure it out given certain situations? All right, so let's get started. So first of all, take a moment to compare these two. How would you say these two ramps, let's say, differ from each other? What's similar about them? You might see like, oh, this one looks much less steep than this one. We're going to talk about what that means. So what is slope? Well, slope is essentially the thing that measures the steepness, so you can write this down into your note, of a line. And there's lots of examples in our everyday lives where we measure the steepness, whether it's ramps, roads, a roof, stairs. Inclines in all of these different kinds of examples need to be taken into account. And there's a lot of different names. Of course, we're going to use slope. That's the name we're going to make use of, and that's kind of the mathematical term. But there's many terms like gradient, angle, incline, or slant that are commonly used as well. So when we're talking about slopes, if we're looking at a graph, when we look at the graph from left to right, so from left to right, that direction as the arrow is pointing, then we can say if it's going upwards, we say the slope is positive, as in these diagrams here. And if it's going downwards from left to right, we say it's negative. And another way to think about it is as your x values are increasing, your y values are going up in these ones. And as your x values are increasing, so as you're going to the right, your y values are going down. As you go to the right, your y values are going down. So that's the idea there. But behind that alternate way of looking at it. So I'll just do one little arrow diagram for both of them like that. Okay, so what do we say the actual slope is? We can define it as a numerical amount, quantity, and we can define it as what we call the rise over run. So what do we mean by the rise? In a sense, how much it goes up or down. What do we mean by it? As in the graph. If you're looking at the roof, then how much does the roof go up or down? And the run is basically how far it goes. Or alternatively, we can think of it as, I'll write it down again. The rise is the change in y value. And your run is your change in your x value if you're thinking about it as a graph. So like we saw in the previous example up above, your graph here, you go across some amount, that's your change in x. You go up some amount, that's your change in y. So that's another way of thinking about it. And we'll take both into account as we go through these examples. Okay, so if we're talking about these examples that we looked at the very start, we noticed that their steepness was different. Now we can put a number to that steepness. So the first thing we can talk about is the fact that the number 3 here, that's how much you're going up or down. So that up or down is going to be the rise. And this part that's going across, that is your run. So if we're talking about rise over run, we can say this has a slope of 3 over 4. And you can leave your slope as a fraction. Okay, continuing along. We can again look at this one. It has the same rise, but the main difference is that it goes up 3 meters, but it does that within 1 meter across. So when you're looking at the slope of a rise over run, well, that's going to be 3 over 1, or just 3. Okay, let's continue onwards to some further examples. So if you aren't in class, we're going to be doing some stuff on the whiteboard, but I will just go through these examples in this lesson here. Okay, so again, here we have a rise and a run. One thing we have to be careful about, though, is in this case, as you're going to the right, you're going downwards. And so when we're talking about rise over run, well, the rise this time, you're actually going down, so it's going to be negative 16. The run is going to be 20 because you're going across 20. And with all of our slopes, when we have a fraction, as usual, we have to reduce that fraction to lowest terms. In this case, you can divide both by 4, and you'll get something like negative 4 over 5. And that is your final slope value. All right, next, what if we have 2 points? How do we deal with that? So what you can do is you can make a rough sketch of where those 2 points would be. 0, 0 would be just right in the middle. And where would 3, 2 be? Well, 3, 2 would be 3 across and up 2. So 3, 2. So if you were to draw a line between the two, let's draw a line. It would look something like this. So the question is, how far across does that line go? How far up does that line go? Well, in this case, we can make use of the points. So we started off at an x value of 0, and we went across 3, or to an x value of 3, because that's what we need to do to get to the other point. So the horizontal change will be 3. What about the vertical change? Well, again, we started at 0, and we went across 3, but then we went up 2. So the vertical change is going to be 2. So now if we write rise over run, the rise is 2, the run is 3, so it's 2 over 3 our slope. All right. And just to continue with a few more examples like that. So again, if we have 2 points, maybe we have a graph given, what we can do is we might need to measure exactly how far across we've gone. So what is that horizontal distance? How far up we've gone. So what are those 2 measurements? And what you'll see is, just counting off along the grid, this bottom measurement, that's going to be starting at 1, going to 4, so you went across 4. The upward part, the rise, you went up 2 units, so 2. So if you do your slope, rise over run, well then what you'll need to do is your rise is 2, and your run is 4. So 2 over 4, which is the same as 1 over 2. So again, you're counting how far across, how far up you've gone. And you'll see in that example, I went to the right first and then upwards, but it would be totally fine if you decide to go upwards first. So if you did this and then went across and counted that like that. So that's totally acceptable too, because you'd see you still have a run of 4, you still have a rise of 2. So both work. All right, and let's just recap some of our ideas about signs of slopes. So try to guess what it should be just based off the definition we went through earlier. And then I will let you know in a couple seconds what they are. Okay, so for this first one, remember sign has to do with what's happening as you go from left to right. Are you going up or down? In this case, the graph is going up, which is going to mean you have a positive slope. And in the second case, your graph is going down. So because of that, we say that it has a negative slope. All right. What about these final 2 examples? So in these final 2 examples, you're wondering like, oh, this isn't going up nor is it going down. So let's think about this in terms of rise over run. In terms of rise over run, does this have any rise? So it has no up or down. So that's actually going to mean the rise, since there's no up or down, neither positive or negative, it's actually just 0. And the run, well, it could be any sort of number, it doesn't matter. But if you actually take a look at the slope, our formula down here, well, if we have 0 divided by, well, I don't know, some number, again, it doesn't matter what it is, 0 divided by anything is, well, just 0 itself. So we can say that in this case, 0 is the slope. So 0 slope. All right, what about a vertical line? Well, we can take a look at this in a similar way we just did the other one, where we can look at the rise and we can look at the run. In this case, we're going neither left nor right. There's no horizontal change. It's just going straight up and down. And so that's going to mean that your run, well, there is no run, is it? Because the run tells you the change in your x values. There's no change in our x values in this case, though. The rise, well, that's how far up or down. And I mean, it's kind of going on forever, but it doesn't really matter what the specific number is. So that's why I'm just writing a squiggle, because it really doesn't matter. And the reason why it doesn't matter is when we go to our rise over run, well, that's just going to be some number divided by 0. And well, can you divide any number by 0? No. So that would actually be undefined. And I'm just going to write that down below. So undefined. And that's because we can't divide by 0. Okay. And so that is another case of a different looking slope that's not necessarily like our previous fractions. All right, so that is what slope is. Rise over run, that's the key takeaway here. You can do it visually through the graph, or if you're given points, you can just sketch out what that might look like and base it off of there. We'll look at other ways of figuring out the slope in the future as well too.